afternoon. I'm honored to welcome you all on today's webinar hosted by Jananvo. My name is Pragya from the marketing team, and I have the privilege of being your host for this insightful session. Before we begin, I'm pleased to introduce our esteemed speaker, Arshdeep Sharma. With over 14 years of experience, she is presently leading the testing team at Jananvo. Her expertise covers the entire spectrum of testing and life science domain while working on the validation of various tools and technologies. And she will be sharing invaluable insights on synthetic data usage and benefits. Without further ado, let's begin this webinar. I encourage you all to actively engage and make the most of this enriching opportunity. Thank you.
Thank you, Pragya. Hi, everyone. Thanks for joining the webinar. So I'll start with the webinar. So today I'm going to present on the topic synthetic data usage and benefits. So this is a much talked about topic in today's world, how it is beneficial for the overall industry and how it is being utilized. We'll have an insight about that. So first of all, let's see what is synthetic data. Synthetic data is artificially generated data that mimics the real world data. So it is created using algorithms and simulations and serves various purposes in data analysis, machine learning, and deep learning. It enables machine learning researchers and data scientists to conduct experiments, test those algorithms, and develop models without exposing sensitive or private information. Furthermore, it facilitates the assessment of model robustness, generalization, and performance under various scenarios. So, if we talk about the life sciences domain or the healthcare domain in general, so before we get the actual patient data to work upon, we can utilize the synthetic data for the analysis purpose and create those models. So it saves a lot of time because since we know that to conduct all those experiments and in the medical domain, it takes around like 12 13 years for a drug to be there in the market right from the beginning when we talk about the initial trials that are being conducted. So when we have the synthetic data already available, so it saves a lot of time. So this is one of the benefits also of the synthetic data. And the second thing is that it also saves the exposure of the sensitive information, since synthetic data is not the actual data, but it mimics the real world data. How is synthetic data generated? Now, synthetic data is created using algorithms and statistical models that analyze real world data to identify its underlying patterns and distributions. So, these patterns are then used to generate new data points that resemble the real data but do not contain any of the original information. It is generated in various techniques and methods. Each technique modifies specific data characteristics and based on application requirements. For example, if there is an application where names and location need to be anonymized, so in that the synthetic data, what this will do, it will mimic the real, like the kind of categories of names. And so also it takes the information that is already available and then utilizes to create the synthetic data pattern. So this is how original data versus synthetic data looks like. So this figure represents the structure of the synthetic data that retains the same structure as the original data, but still it's different from each other. So the pattern is going to be the same. So now we will talk about some of the processes of synthetic data generation. First is a random sampling technique to generate the synthetic data. So this data generation through random sampling involves the creation of data points by randomly selecting values according to statistical distributions observed in the real world data. So this method is straightforward, but it has limitations in accurately representing the interdependencies found in the authentic data sets. Real world data often exhibits special statistical patterns, such as Gaussian distribution or skewed structures. Now, what is skewness? If we talk in generic, skewness in stats is represents an imbalance and asymmetry from the mean of a data distribution. For example, if we talk about a balanced stats figure, that is where mean is equal to median. It means if we draw a curve, then the center will be the mean. But in skewness, what happens in normal, we have a symmetrical bell curve. It means the median and mean and median are same. In skewed data distribution, the median and the mean are different values. Now, what does this mean? It means either the mean will be left oriented or right oriented. So if it is right oriented, it means it is right skewed. A right skewed distribution is longer on the right side and its peak is on the left. Generally, there is one peak at the center in normal distribution, and the rest two curves, they are equally distributed. But in right skewness, it will be like right side of the peak is on the left, and in the left skewness, the distribution is longer on the left of its peak than in its right. So this way it is, this is one of the characteristic which may not be fully captured by the simplicity of random sampling. Next is bootstrapping technique, or to generate the synthetic data. Now, the application of the bootstrapping involves resampling from an existing dataset with the replacement. So it creates the synthetic datasets that preserves statistical properties observed in the original data. So this method works by randomly drawing samples from original datasets, allowing individual data points to be selected more than once. So for example, if there is a dataset, there are some random values we pick up. So there is a probability that we might select those same values twice. That's what it is saying. So through this process, bootstrapping generates multiple synthetic datasets, each mimicking the statistical characteristics of the original data. So this technique is like constructing confidence intervals and accessing the variability, resampling from the observed datasets. Thus, it provides a robust and versatile tool in statistical analysis. Next we have is rule-based with domain-specific to generate synthetic data. Here, the synthetic data is created based on predefined rules and constraints. So here, the domain-specific knowledge of relationship and dependencies within the data is applied. So here is an example. In finance, rules may dictate the correlation between income and expenditure. The system systematically applies these rules, considering the constraints and interdependence. For example, if the income and expenditure, they grow proportionally, they are directly proportional, they are inversely proportional, or to generate the realistic and representative synthetic data sets. So by incorporating the domain expertise, rule-based systems enable the controlled and synthesis of data and aligns with the intricacies of real-world scenarios, offering a tailored and interpretable approach to synthetic data generation in context where explicit rules govern the underlying structures and relationships within the data. So this is where we have some predefined rules and constraints that need to be considered while creating the synthetic data. Next is generating the synthetic data using statistical methods. So there are various statistical model techniques for synthetic data generation that involves employing parametric models like Gaussian distribution. We may call it the normal distribution as well, where the mean and median are where the mean and mode are the same. So it is represented by a balance curve where there is a symmetry. So to replicate the statistical properties of real-world data, the process begins by identifying the underlying distribution and parameters that characterize the observed data. For example, if a data follows a Gaussian or a normal distribution, the mean and standard deviation are estimated. How come? because in that curve the mean is always in the center, so we can easily pick the mean in those values. Sometimes the values can have like normal values. For example, if we say there are 10 students in a class and they have these marks, so it is easy to calculate the mean because the distribution will make that curve, and then in the center there will be the mean, and the standard deviation is also easy to calculate. This can be estimated in the normal distribution. And also there can sometimes the data can be like they have some values like 0 to 20 and then 21 to 40. So in this case we need to pick the mid value, and accordingly we'll calculate the mean and the standard deviation. So the statistical model that generates synthetic data points by sampling from the identified distribution, ensuring that the generated data aligns with the statistical characteristics of the original data set. So what does this mean? It means that what synthetic data we are producing, it shall be in alignment with the statistical characteristics of the original data. If the original data has a normal distribution, then the synthetic data generated shall also follow that pattern. So this approach is effective for capturing complex relationships and dependencies present in real world data, providing a controlled and interpretable method for synthetic data generation based on the statistical patterns observed in the target domain. So different we can say different values or different data or different problems have different kinds of variations when we are talking about the statistical patterns. So the statistical pattern of one distribution may not be same as the other one because of the values being observed. Now we will talk about the measures of synthetic data. Now, suppose we have generated the synthetic data, right? Now, it is also important to measure the accuracy of that synthetic data. Like to validate that is also important. Otherwise, it is of no sense. If, say, I have generated that synthetic data, but it is of no use in real life or my real time scenarios. For example, if I talk about the clinical domain, so we have some patient data, and we on the basis of that we have generated some synthetic data, some data sets, some series data sets, SDTM data sets that have almost the similar values. They like age, height, all those columns or all those values which we generally have in the data sets. Now we have created that, and it is being utilized as well. But how much accuracy is there, that is also important to calculate. So there are some methods which measure the accuracy of the synthetic data. So one of these is chi-square test. It is a measure to find the differences between the observed and the expected frequencies of values in synthetic and real data sets. It means how much deviation is there. So this is my real data set, and this is the one that I have synthetically created. So what is the difference between the expected frequencies? So the lower chi-square values indicate higher accuracy and vice versa. So the less the difference in the frequencies, so more the accuracy. The more the difference in the frequencies, the lesser the accuracy. The next is the kernel density estimation, which compares the probability density functions of synthetic data and real data using kernel density estimation. So closer match in shapes indicates greater accuracy. Next is mean squared error, which computes the average squared difference between individual data points in synthetic and real data sets. The lower MSE value indicates greater similarity. So these are some of the methods by which we can gauge out if the synthetic data we have created, how much accurate is that. Next is Gaussian distance, which means the distance between probability distributions by calculating the minimum cost of turning one distribution into the another. So the lower value signifies higher accuracy. Similarly, Kolmogorov stats to compare the cumulative distribution frequencies of the synthetic and real data. So the smaller statistic suggests better similarity. Now we have various methods in Python that are used for synthetic data generations. There are a number of techniques uh, based on the specific use case. It also depends upon what kind of domain we are in and what kind of problem we have. So the same method can't be applied everywhere. So if we are talking about, say, the creation of the synthetic data for a particular problem, for we are talking about creating the data sets. If these are of our SDTM data set, or the creation of these data sets, so that depends upon the problem statement, what problem statement we are having. So depending upon the problems statement, we have different ways to create the synthetic data. So first is generating a synthetic data using Faker Python library. So this is used to generate realistic randomized fake data for various purposes, such as testing or populating databases, CDM, or creating sample datasets. It provides a simple and customizable way to generate fake names, address, emails, and other type of data to simulate real world scenarios in a controlled and privacy preserving manner. So it ensures that even the original data is not exposed, and that basic needs that are sufficed through the real world data, those are there in the synthetic data. Next is generating a synthetic data using scikit-learn library. So these are the powerful libraries for machine learning. They can be used to generate synthetic datasets with specific characteristics, especially for classification problems. So we are not applying all of those in our tools. It depends upon the problem statement. Next is creating a synthetic data using bootstrap sampling in NumPy library. So this we have been using NumPy library. Bootstrap sampling is a resampling technique that involves randomly drawing samples with replacement from a dataset. This technique can be generated by using NumPy library in Python. Next is the one that we talked about, generating synthetic data using Gaussian or normal statistical model in NumPy library. So Gaussian statistical models are used to generate synthetic data by assuming a normal distribution. It means a distributed curve where the mean is always in the center, defined by mean and standard deviation parameters. This can be achieved through using the NumPy library. Next is application of synthetic data in machine learning. So it helps in data augmentation process by augmenting existing datasets, helping improve model performance by providing additional diverse examples for training. Synthetic data aids anomaly detection by creating realistic outliers and anomalies, allowing machine learning models to better identify and handle unexpected patterns or anomalies in real world data. So what does this statement means? For example, if we have some in something in the real world data where we are doing a study on a particular therapeutic area, so there can be some outliers as well. Like if we are studying the cancer patients, so there may be a study where there are people who are outliers of those values. So that's why it helps in aiding that anomaly detection if there is some. Next is synthetic data allows to reduce biases present in real data that can be addressed, promoting fairness and reducing algorithm bias in machine learning models. It also supplements the real world datasets, providing additional examples for model training, especially in scenarios where obtaining sufficient authentic data is challenging. Next is the limitations of synthetic data. So there are some limitations to synthetic data as well. So first is synthetic data may lead to overfitting, where the model performs well in synthetic data but poorly on real world data. This is because the synthetic data may not adequately represent the full range of real world data variations. So this can, in this case, this can be corrected using a particular therapeutic area shall be defined while creating the data to surpass the limitations. So let me explain it more. For example, we have a study where there are some cancer patients, right? So we have some data where, say, the synthetic data is saying that a patient has age of 100 years. But if we are talking about the real world scenario, generally this case won't be present because of the, even if the treatment is ongoing, then that may last like 4 5 years, what is the original date from where it had started, the the problem had started. So this is where the data may lead to overfitting. It means that that 100 years of age, it is not fitting in that particular scenario what we are talking about. That's why therapeutic area shall be defined. So different therapeutic area, they have different values for those particular variables. So while creating the data, if we define it, so then we can surpass this limitation. But this is one of the major limitations that are being faced for the synthetic data. So this is an example of a clinical domain or our data sets, but this can be in generic scenario, this can also happen. Next is creating accurate and realistic synthetic data often requires domain expertise to understand the underlying patterns and relationships in the real data. Yeah, this point is also very important because when we are creating the synthetic data, it requires a lot of study and domain expertise. So if we are talking about creating data sets, so we need to understand what those particular data sets contain, what are the values that are there in those particular columns, and also what does that mean, and those values, like what is the range of those values. It can't be a case if it is say the range generally lies from, say, if we are talking about uh, any particular variable in that particular data set, how the deviation can be there from that range generally. So some of the variables, they are like actually collected from the patient, some of them are being derived. For example, our height and weight, those are the ones that we actually take from the patients. And sometimes we calculate the BMI, that is also one of the values in the data sets in the columns. So that is being derived from the original values, what we observed and what we calculated. So this is also important to understand. Next is generating high quality synthetic data can be computationally expensive, especially for complex data types like images or natural language. Next is while synthetic data can protect privacy by not using real world data, still there is a risk of re identifying individuals based on the synthetic data, especially if it contains sensitive attributes. Yeah, this is also one of the important points. Even though we are not using the original data, but those patterns might also help to identify the individual data which for which, like, we are very very sensitive in our particular industry in which we have been working. So because it is all revolving around this, that the generic information of the patient shall not be revealed at any point in time. That's why we are using all these masking techniques or anonymization techniques. So here is about our Datalution project, which is one of our tools that is an all-in-one solution for generating synthetic data for testing, electronic data capture screens, edit checks, data management activities, programming, and stat setup activities. Here, we are trying to generate the synthetic data using our tool with automation. So, our product generates meaningful synthetic data that simulates real world scenarios, enabling you to test things like edit checks, CDISC, dataset generation programs, data visualizations, and TFLs generation programs under a wide range of conditions. It makes clinical trial simulation and synthetic data generation for healthcare easier. So, with our product, we can create large and diverse datasets quickly and cost effectively without the need to first collect the real data, thus saving a lot of time. So, with this, I would like to thank each one of you for being a part of this webinar. Thank you.